Alright, in this video we're going to start talking about properties of functions. The two big properties we're going to talk about today are domain and range. The domain of a function is going to be the set of all inputs, meaning x values. Or independent variables is probably the better choice, but we'll stick with x values. When we're finding the domain, we need to consider what x values cannot be used. So instead of saying everything that we can use, we're just going to say, let's use everything except this, this, and this. Now there's two big places where this is going to happen. First is if the function has a radical. And second is if there are variables in the denominator. So variables in a denominator. Now if we have radicals, we want to make sure the radicand, so radicand, that's what's inside the radical. So if you think square root of 2, 2 is the radicand. We need to make sure the radicand is greater than or equal to 0. Right? We can't take the square root or can't take the square root of a negative number. This really only happens for even powered radicals, but most of the time we're going to be dealing with square roots, so it's not going to be that big of a deal. If we had the third root of a negative number, that's okay. So again, technically this is just for even powered roots. And then if we have variables in the denominator, we have to make sure that the denominator is not 0, right? Not allowed to divide by 0, so we have to ensure that our denominator is not going to be 0. So let's look at a couple of examples here. Find the domain of each function, square root of x plus 3 and square root of x over x minus 5. So here we have a radical, so we need to find the radicand. And that radicand is x plus 3. We need to make sure that x plus 3 is greater than or equal to 0. So our domain is going to be every single x value that is greater than or equal to negative 3. That's going to be our domain. Any x value that is greater than or equal to negative 3 will work in this function. Any value that's not on this interval is not going to work. So we take negative 4 plus 3 is negative 1, square root of negative 1. Technically doesn't exist, although we oftentimes call that I. So, domain greater than or equal to negative 3. Here we have two issues. We have a radical, and we have variables in the denominator. So we have to take care of both of these things. So first let's look at the radical. The radicand is x. We have to make sure x is greater than or equal to 0. Well, finished. We don't have to solve anything. That one's done. Now we need to make sure that our denominator, x minus 5, is not equal to 0. So to solve that, just add 5 to each side. So x cannot equal 5. So our domain is going to be all x greater than or equal to 0 with x not equal to 5. Right? If we plug 5 in here, we're going to divide by 0, and that's going to be a problem. So all x greater than 0 except x equals 5. So the last thing we need to talk about is the range. The range of the function is the set of all outputs. And that's generally going to be our y value, although again, technically we should be saying dependent variable. When we're looking at the range, we really need to think about what the graph is going to look like. We need to find if there's any y values that are not going to be used. So it's the same type of thing as with the domain. We're just going to say what isn't in the range. So these are two functions that you may or may not know what they look like now, but you'll know what they look like fairly soon. So if you were to graph this, it's going to look something like this. It's just a sketch. It's not going to be exact, but it's going to look like that. And if you were to graph the other one, it would look something like this. So if we're looking at those graphs, we need to think about what y values are not going to be used. Well, if we're looking here, this arrow is going down forever. So everything all the way down to negative infinity is going to be used. And then this kind of flattens out, and it doesn't look like we're going to hit y equals 0. This side flattens out as we go over here, so it doesn't look like we're going to hit y equals 0, but it does go all the way up to infinity. So it looks like we're going to hit everything except y is not 0. So there's a couple ways we can say this. We can say that the range is all real numbers except y is not 0. You could just say y is not 0, and that would work just as well. On this one, it looks like we're at 0 and then we're going to grow forever. We have to think, can I actually be 0, or does that just get really, really close to 0? If we put negative 6 in here, we get negative 6 plus 6 is 0. Square root of 0 is 0, so the output is 0. So our range here would be y is everything greater than or equal to 0, right? We're greater than or equal to 0 because we're actually allowed to be it. You could also, if you wanted to use interval notation, do bracket 0 and then infinity with a parenthesis on the other side, because we can be 0. So that's going to do it for this video, and we'll see you in the next one.